Good evening, students. I am going to record this final exam review in different parts. I'm going to do a part per module, and we'll be covering a lot of different basics within the module. But keep in mind that I cannot cover everything that we've covered the entire semester in 1 hour. So please bear with me that I picked out the topics based on your test results on which ones to cover. So before we get into our first, I just want to talk about a little bit about the final exam logistics. You will have 90 minutes to take the exam. It is 45 questions and they are all multiple choice. Remember that it is cumulative, meaning that it covers all modules and only can be entered once. That means that once you start the exam, please make sure that you have 90 uninterrupted minutes. So you will not be able to pause the exam or leave and come back to it. So once you start, make sure you have 90 minutes to complete the entire exam in one sitting. All right, so now we are going to cover the math of physics in this recording, and some of the topics that I'm going to just touch on are conversions, sig figs, and scientific notation. All right, so the first thing is sig figs. Remember that it's fast, it's easy, and a lot of you miss little points off later on the semester because you forgot about significant figures. There basically are two rules. There's one for adding and subtracting and one for multiplying and dividing. Remember that when adding or subtracting, you're going to have to note the accuracy of the measurements. So that means that you're looking to see how accurate that measurement is. Is it 0.1, 0.01, or 0.001? Which one is the most accurate? Another way to think about it is which one measures to the smallest amount? So the most accurate in this case would be 0.001. The answer can be no more accurate than the least accurate number that is used to calculate it. So again, for adding and subtracting only, you have to determine the least accurate number and make sure that your answer is rounded to that place. So if it is 0.1 plus 0.001, your answer is going to have to be rounded to that least accurate, which would be 0.1. So you have 550 grams plus 8.6 grams. So the first thing you have to do is determine which one is the least accurate. So this number is measured into the hundredths, and this one is measured into the tens place. So this one is going to be your least accurate. So when you add them together, you should get 14.1 grams. I rounded it to the least accurate place, which is that 0.1 or that tens place. Here's another example. We have 52.09 milliliters minus 49.7 milliliters. Remember, if we have the hundredths and then the tenths, this one's going to be your least accurate. You're going to subtract the two, 2.35 milliliters. But remember, we have to round to the least accurate place, so that's going to be the first decimal place to the right, and we should get 2.4 milliliters as the correct answer with the correct significant figures. Remember, when multiplying or dividing, you must count significant figures. The answer can have only as many significant figures as the least of the numbers used to get it. A lot of you guys apply this rule to both addition and subtraction and multiply and dividing. So remember, this is just for multiplication and division. So here's one sentence rule for counting sig figs. Remember that all digits are significant except zeros preceding a decimal fraction and zeros at the end of a number containing no decimal point. So here are some examples on how to count significant figures. We have 0.0045. You have to know that this has two significant figures. These do not count. But if I added a 1.0045, this number is going to have 1, 2, 3, 4, 5 significant figures. All right, now moving on to scientific notation and powers of 10. A lot of you guys on that last lab had trouble graphing scientific notations, and maybe you need to review this topic again. Mathematical operations with scientific notation will also be covered on this slide. Something that I like to remember is the word LARS. L, left add, LA, right subtract, RS. So what that means is that when adding and subtracting the power of 10, you must be the same. For an example, 4 times 10 to the third plus 5 times 10 to the fourth. So the first thing you have to do is rewrite the 5.4 10 to the fourth. Since you need to subtract 1 from the exponent, you're going to have to move the decimal place to the right. So you're going to have 4 times 10 to the third plus 50 times 10 to the third equals 54 times 10 to the third. You have to understand that this number and this number are the same thing. You're going to convert the final answer back to scientific notation. 5.4 times 10 to the fourth. We add because we move left. Remember that. When multiplying, you're going to take the product, then add the power. So here's an example. We have 4 times 10 to the third plus 5 times 10 to the fourth. We're going to multiply the first two numbers. So the first two numbers is 4 times 5, and that's going to give us 20. And then we're going to add the exponent. So 3 plus 4 gives us 7. So we're going to combine our two parts, 20 times 10 to the 7th, and then if necessary, we need to convert back to scientific notation. So since this is not in scientific notation, we're going to move the decimal place to the left. Remember, left, add, and we should get 2.0 times 10 to the 8th. That should be an exponent there. Sorry for that typo. When dividing, you're going to divide, then subtract the power. So our example is 20 times 10 to the 8th divided by 5 times 10 to the 6th. So we're going to divide the first two numbers. 20 divided by 5 equals 4. Then subtract the exponents, 8 minus 6, and that's going to give us 2. Combine your two parts, so 4 times 10 to the squared. If necessary, convert back to scientific notation. So that answer would be correct. That is it for the first module. Now moving on to the second recording.